Northern California coastline supports incredible biodiversity, vibrant ecosystems, and stunning views, which in turn leads to a plethora of recreational opportunities and tourism. The San Francisco Bay Area offers a seemingly perfect blend between nature and metropolis, with protected parks nestled amongst and around one of the most densely populated cities in the United States. The Golden Gate National Park covers a coastline ranging from the heavily populated Ocean Beach to the remote Muir Beach, ranging between Marin, San Francisco, and San Mateo counties. Unfortunately, much of this unique coastline is undergoing dire threats that cities and sanitation districts are in need to assess proper water discharge.
For example, the Oceanside treatment plant lies just south of the city's beaches and releases millions of gallons of effluent each day. Studies and data collected by the Pacific Institute identifies an approximate 30 vulnerable wastewater treatment plants that are responsible for direct output into the San Francisco Bay and 9 plants along the Pacific coast. This enormous amount of effluent entering the saltwater of the ocean, even after treatment, introduces its contaminants to marine life and particularly marine invertebrates. Wastewater contains microorganisms and excess nutrients which, if present, can cause serious problems and illnesses in our coastal areas.
Coastal monitoring programs such as LIMPID surveys the biology in rocky intertidal and sandy beach ecosystems to provide publicly accessible, scientifically sound, long-term data to inform California marine resources. Naturally occurring organisms such as the Pacific mole crab have been used to monitor pollution in pathogen sites and can serve as bioindicators. Such organisms and communities also have the potential to be used as indicators of ecosystem recovery from a spill or chronic contamination. A range of bioindicator species or organisms for use in monitoring the level of pollutants present in coastal environments and assessing the recovery of damaged ecosystem needs to be established for the California coast.
Sand crabs tend to be abundant and relatively easy to find, making them ideal to understand population dynamics on the beach. As one of the largest filter-feeding herbivores on the beach, they form a vital link in the food chain from ocean to sand crab to predator, giving us a picture of the overall health of the shore. Our results showed that proximity to the wastewater plant may potentially play an important role in abundance. We created and overlapped kernel density maps of sand crab abundance and flow rate of wastewater treatment plants. This tool calculated the density of sand crab abundance and flow rate of wastewater treatment sites so that we could view whether or not the area of higher or lower abundance were close in proximity to wastewater treatment plants with higher or lower flow rate. These maps reveal that in some cases, the magnitude of crab abundance increased as the distance from high flow rate wastewater treatment plants increased. There appeared to be no relationship of crab abundance with proximity to low flow rate wastewater treatment plants.
We also conducted an inverse distant weight, or an IDW analysis, to determine the relationship between the magnitude of the variables. Using the IDW analysis, interpolation determined the cell values using a linear weighted set of sample points. This geospatial method assumes that the variable being mapped decreases in influence with distance from its sampled location. Like a missing puzzle piece, we can depict how the flow fits into the gap between the abundance of sand crabs along the coastline, indicating that species are further away from higher flow sources and in lower density relatively closer to these sources.
We also factored in the importance of MPAs, or state marine protected areas, within sampling sites. As depicted by our map, higher abundance sites were located closer in proximity to marine protected areas in comparison to unprotected areas. There appeared to be no special protections afforded by land-based GOGA areas. This demonstrates the potential of MPAs to provide an indirect protective effect for sand crab populations by restricting fishing and other human-related impacts. These protected areas are critical because they help sustain the overall health of marine ecosystems and resources, ultimately benefiting even small organisms like the Pacific mole crab. Observing how indicator species such as sand crabs are impacted by human activities and how impacts are mitigated by protected spaces is vital for understanding how to better manage our ocean resources. MPAs are just one type of ocean management tool that can potentially influence effluent discharge practices. When used effectively, these special areas ensure a healthy coastline for generations to come.
Manna from heaven, sweet nectar of life. Hey, this is our spot. Go on, get out of here. Hey. Yeah, that's it, fella. Just keep on swimming. You got that. Too right, mate. Oh, I got a live one here.
Hey, have you seen my dad?
Gotcha. Hey, come back here. You let him go. Hey.